Okay, Kubernetes storage gurus. Yeah, okay, not quite. I know, true guruship only comes with time and experience. But if you've made it this far, you've taken a big step and you really should congratulate yourself. Because storage can be a pretty dry topic, I get it. So no joke, well done, you've made it through the hard stuff. But let's spend just a couple more minutes going over some of what we've learned and, I don't know, maybe a chance to add a bit more clarity. So, the whole idea of volumes or a separate persistent volume subsystem is to decouple storage, which we're calling volumes, yeah, from pods. So getting away from that nasty place where storage comes and goes with its associated pod. Because remember, pods are ephemeral by nature, here today, gone tomorrow, and that's cool and all for stateless stuff, but my guess is you're unlikely to want your data to be ephemeral. So, instead of that tight coupling of pods and storage, we've got this model where volumes themselves are full-blown citizens in the Kubernetes ecosystem. We create them, we configure them, and we even destroy them independently of any other object in the cluster. So, it's like this. Stick your storage system here on the left. Maybe call this the back end, yeah? It's what's got the actual disks or whatever. That plugs into Kubernetes via plugins. The model going forward is to develop those as CSI plugins so they're out of tree and easier to iterate on, yeah? Basically, they don't need to be built, linked, compiled and shipped with the core Kubernetes binaries. Anyway, look, once the storage is plugged in, we independently create persistent volumes, which tie back to actual devices or shares or whatever on the storage back end. So a takeaway point, right, is they are not just some attribute of a pod, they are their own objects. Now, in order for a pod to use a PV, it needs a PVC, which is a claim on the PV, like a ticket to use it, yeah? Then within a pod spec, you reference that PVC and mount it into a container. And that's fabulous and all, but it is a bit manual. To make it more dynamic and scalable, and to get the good stuff like volume resizing, we need storage classes. These define a kind of template for PVs and let us carve them out on demand. And I reckon that's it. Whew. The tough stuff done. I think definitely onto the more interesting stuff moving forward. Speaking of which, coming up next, we're going to take a look at how we take our code, if then this and that, yeah? And start packaging it for Kubernetes.